Please introduce yourself and briefly summarize your education and professional background.
Sure. Thanks, Todd. So I'm Gregg Semler. I'm the CEO and founder of InPipe Energy. Um, I'm an entrepreneur. I have been focused on building energy and water companies since 2000. So I'm a climate tech entrepreneur. I started InPipe Energy in 2016 because I saw this enormous opportunity to generate renewable energy from existing infrastructure. I went to college at Columbia University and earned my BA, and then I have a MBA from the Tuck School at Dartmouth College.
All right, let's talk a bit more about InPipe Industries. And so you say that they do water pressure energy. Can you tell me what that is?
Yeah, so water or it's basically hydroelectricity. Let's start there. Hydroelectricity is well known as the lowest cost source of renewable energy. It's the concepts, the physics behind hydroelectricity have been around since physics began. So it's really well understood as an electricity source. And then the way water is conveyed is similar all over the world. It's basically water flowing in pipelines instead of where typically you see hydroelectricity like in rivers, streams, and things like that. But the same physics, the same physics applications apply to water flowing in a pipeline. So what we do is we basically take the flow of the water and the pressure that builds up in the water and generate energy. So it's basically using the principles of hydroelectricity to produce energy, but it's in a pipeline. So it's very consistent. You know exactly how much water is flowing through that pipeline. And because it's in a pipeline, there's no environmental impact. So hydroelectricity is well known as the lowest cost source of renewable energy, but oftentimes environmentalists really object to it because of its impact on fish and habitats and makes it very difficult to harvest energy from the flow of water anymore. But what InPipe is doing is really taking advantage of existing pipeline infrastructure so that we can bring this new source of energy to the world.
Can you describe how it works? Is it like inside the water pipes? And how is it going? Typically, like I see water there, your water spinning turbines that then creates electricity. Can you go into details exactly of how what the water is? It the water? Is it the water pressure? What's converting it
It's
to electricity
yeah.
now?
So energy, it's a energy is the way energy is created is a combination of the flow and the pressure. So it takes water flowing, but it also takes pressure. So it's that combination. And so as water is moving through pipelines, there's two ways that the pressure happens. It either happens through pumping in these pipelines, where there's big water pipes pushing water through, or it comes from gravity, which is water moving downhill. And we typically go into gravity-fed systems. So it's basically a micro hydro turbine, which basically is in the flow of the water. It spins a turbine that spins a generator, electric generator, that's connected essentially, in our case, to the grid panel, to the grid. And so it's a very efficient way to create energy is by running a turbine with water in it. I mean, there's all kinds of turbine technologies, whether you're using gas or steam or oil, it's well understood that things that are moving or flowing is energy. And if you can harvest that energy, like what we do, we focus on water, then basically taking out the energy content of that water and to produce energy is what we do.
Do you need a especially large pipes to be able to do this? I'm picturing, can you do it like on, water towers, or do you need to have like a very large, initial pipe, but or can this be used in even smaller pipes, at the neighborhood basis?
It can be used in any size pipe. I mean, the principles are the same, right? It's flow and pressure in a pipe. But to your point, flow and pressure happens in different pipe diameters. Like at your home, it's maybe a 1 inch pipe or a 2 inch pipe. And the challenge there is you just don't have the amount of flow on a continuous basis to produce an economically viable product. So you could do it. And, we get asked that all the time, like, can I do this at my house? It's really you just don't have enough flow on a continuous basis to make the economics work. So some of your readers might want to just do it for fun, but you just can't do it like as a business. So what we do is we look for customers that use larger amounts of water in pipelines. And so those are like cities. Those are water treatment facilities, mining companies, agriculture, data centers use massive amounts of water in pipelines. These industries use lots of water and lots of energy. And so in those industries, they have pipelines that range in size, let's say from 8 inches to 110 inches. So really massive amounts of water. And depending on how much pressure and how much flow you have in those pipelines determines how much energy you can produce. It's megawatts, many megawatts of energy can be harnessed from these pipelines.
Do you have a particular turbine that you like to use? I'm wondering, do you make like a module that kind of fits into an existing pipe system and you kind of like add it into the system, or do you have to put a turbine inside existing pipes?
Yeah. So in my first company, before InPipe, I was involved in a company that had a turbine that was like a wind turbine. We were commercializing this product, and it would go in a pipe, spin, and generate energy from it. And the idea was to create like a wind farm inside of a water pipeline. And it was really cool. It was really elegant, and we commercialized it in Portland, Oregon, and in Riverside, California. But what I realized is it's very challenging to get people managing these water pipelines to stop the water, cut open the pipe, put a turbine in it, put it back together to generate energy. I think it would work if new pipelines were being built. But I started InPipe Energy because I came up with a different solution than that. So at InPipe, what we do is we create something called a bypass. And a bypass is basically a separate structure from the main pipeline. Picture a main pipeline, and an offshoot of it would be a bypass. And so it's a pipeline that connects to the existing pipe. And in that bypass is our product, which we call the Hydro XS. And so through electrical controls, sensors, and so forth, we can manipulate the water in the main pipeline to go into the bypass, into the turbine of the Hydro XS, and generate energy from it. And the benefit of that is that we can install our system in weeks without even turning the water off. So for our customers, we don't impact their delivery of water even while we're installing the system.
Does this have any effect overall on the flow of the water, or the pressure that's coming out of the system once this is added?
We don't change the flow of the water, but we do take out pressure. And so they're taking out pressure anyway. So in most of these pipelines, they're either delivering the water back to the sea, or they're filling a tank or an aquifer, a storage tank you referred to. They're reducing the pressure intentionally to deliver the water at a certain pressure. So what our customers do is they deliver water at a certain pressure. They manage the pressure and the flow so that when you turn on the tap, it comes out at the right pressure. Our system is designed to do the same thing to help them do that. And so they typically use control valves to manage the pressure in these pipelines. And, and so we've designed our system to replicate the functionality of these control valves. So it has the same impact on their system as they're already doing. And all we're doing is taking out that pressure through a microturbine, so converting it to electrical energy from mechanical versus friction. So they use friction to burn off that pressure. And what we do is we use a microturbine, which generates energy.
Could you describe a little bit more about the like the size and the workings of this microturbine, and also I want to get into how with the electricity and how does that kind of engineered?
A microturbine is, is a technology that's been around since the Greeks 5,000 years ago. And it basically takes water flow and pressure and spins. And there's various turbine designs depending on, whether you have high flow, low pressure, high pressure, low flow, medium amount of flow, medium amount of pressure. So typically turbines are custom made to a specific site location. And so it's a custom made device that's made to generate energy. And they're like you could picture a wind turbine, but a hydro turbine is the same idea, is that you have a fluid and when you put your turbine in front of the fluid, the turbine spins, and the turbine spins a generator that creates the electricity. So it's an electrical generator. We happen to use an asynchronous generator, which means that we sync to the frequency of the grid. And so we connect to the grid or to an industrial facility, just like a solar panel would. And so the speed of the generator matches the frequency of the grid. And so as the turbine spins, it's delivering electricity to the facility or directly to the grid.
Do each of your the electrical portions, I don't know if it's like a transformer, do they need to be added in to match the electricity grid that you're adding into, or can each one adapt internally? So you just need to have one of those that can adapt on its own.
Yeah, it adapts on its own. It's designed to match the grid.
And how large is this whole system, especially with with the turbine, just for physics, since we don't have um,
Yeah.
pictures, I'm just kind of curious.
Yeah. So it's about the size of a refrigerator on its side. So let's say it's like 5 feet high by like maybe 8 feet long by 4 feet deep. And that generates the equivalent amount of energy as, say, 2 acres of solar panels.
Okay, so since I don't really know, how does a solar panel or this particular system attach to an electric grid? What a little bit about how that works.
Yeah, so we create AC power. And the grid operates on AC power. So our generator is compatible electrically with the grid. So we create what's called 480 volt three-phase power, which is sort of the power requirements for the grid. Solar generates DC power. So they use an inverter, a component called an inverter, which takes that DC power and converts it to AC power and then connects it to the grid. So there's electrical, you have to match the power requirements for where you're delivering the electricity to. And so, there's all kinds of generators out there to match, like, if you're doing it in Europe or Asia or here, depending on what the power requirements are. But that's something that we can adapt to with our technology.
Okay, now that you've kind of explained it, it seems like it's pretty much existing equipment and a lot of common engineering that people have understood for a long time with pipes and turbines. Why
Yep.
haven't I seen something like this before outside of the rivers and the streams that we're all aware of?
It's a really good question, and I don't know the answer. I just know that I've been working on this for 10 years, and I really haven't seen anybody else doing what we're doing. And I think the reason is that the water industry and hydroelectricity is like its own industry, and they're particularly focused. I guess us humans like to focus on things, right? And so people in water in these pipeline operators, for example, they're mission driven. They mostly care about delivering safe, clean drinking water. That's how they win. And so that's what they think about. And these customers are the largest customers for electric utilities, but they never talk. And then there's electric utilities who are here to deliver electricity, and these water customers, like let's say data centers, are massive users of energy. They're also massive users of water, and they never talk. So I just think that because I focused the early part of my career on energy, and then I learned about water and started thinking about like, why don't we produce energy from water pipelines? It just, for some reason, it just came to me that this source of energy exists, and what we need to do is figure out a way to simply uh, uh, integrate energy technology with water technology. So the product that we've developed is more than just a turbine because our customers, as I mentioned, care about delivering water to certain pressure. Turbines aren't precise enough. They just take out pressure, but it's not precise enough for what water companies care about. So we integrated what we call pressure management controls with energy generation, brought them together in a way that I think makes a lot of sense to the people managing this vast water resource.
Do you feel like you've kind of got a handle on it and understand and worked out most of the details, or are there still some pieces that you feel like, could be improved and maybe fixed up a little bit?
Well, I think that the challenge is really getting to scale because it's expensive and energy is a commodity. So you have to, be driving down costs all the time, and you're competing with other sources of energy. There are a lot of benefits to doing hydroelectricity, but when you're an entrepreneur and you're building your first few units, the costs are expensive, and we have to find ways to overcome those costs in order to become essentially an energy commodity that's used everywhere in the world. So we have to innovate really on the cost side, more than on the technical side. Like it exists. Like, I mean, most people, I mean, our customers are all engineers, and we can convince them that our system works safely and reliably, really with one meeting once they understand what we're doing. So
Okay,
it's not
so
so much more innovation, it's really about getting to scale.
sure. So let's say an engineer is, keen on doing something in the water or electrical system. I'm thinking it would probably be the water engineers. Is that correct?
Yeah, yeah.
Let's say they're looking into doing this. What would they need to look at to try and incorporate this in their design and how to think of a kind of a combined beneficial system?
Yeah, well, they have to look at the hydraulics of the system that they're designing. So, I get asked all the time, like I have a stream in my backyard, can I generate energy from it? And you can, but you have to figure out how much flow do you have and how much pressure do you have? Because that's going to determine how much energy you can produce. I mean, it's that simple. You just have to figure out what the flow and the pressure is, and then you can determine the energy, and then you can determine the product. It's challenging to get the data that you need to design the system. So if you're an engineer trying to figure out how can I, harvest this river in my backyard, you have to figure out like how constant is that flow, and what's the pressure change that I can do in this particular. That's the challenge.
Okay, so I think another big lesson from this is that, you were able to look at two things that kind of hadn't been thought of before because you were thinking, not just about each project. What advice might you give other engineers who, they're doing their daily jobs, focused on their projects, to kind of think of larger issues that maybe they normally wouldn't think of, but they're there.
Yeah. Well, I think that what we don't spend enough time on as humans is realizing that we're part of a bigger system. And that we're all part of the same ecosystem, whether you look at it as we're a part of the planet or bring it on down. But I think during COVID, we could see that, when there weren't as many cars on the road or as many people out, you know, our rivers and streams kind of cleaned up and the air became cleaner, and we also appreciated it more and things like that. Um, so for engineers who are so focused like on solving a problem, fixing that thing, realize that like there's it's part of a system. And when you design something, it impacts something else. And just try to understand the impacts down the way. And so an example of that is like in our industry in California. Where are you located?
I'm in Colorado.
Okay. So we just installed a system in Aurora, Colorado. I don't know what part of Colorado are you in?
Steamboat Springs in the mountains.
Okay, beautiful. What happens in water is that there's a big there, there's in Colorado and California, Oregon, Washington, the West Coast, we have an abundance of water. But there's a lot of places that don't have an abundance of water. And what they're doing is they're just building bigger reservoirs to try to capture rain and capture every drop of water they can. But water takes a lot of energy. That's the point of this talk, is that energy and water are very closely related. So when you're just building more reservoirs or figuring out how to basically store more water, you're adding to the energy requirements of the planet. And so, when you're an engineer thinking about building water systems, think about how to reduce the energy intensity of that water, because we need the water also to deliver energy, and we need the energy to deliver water. And so my point is that it's all part of a system, and whatever you're designing has impacts on something else, and really trying to understand that. And if you want to be innovative, it's really trying to understand, overall, what is the customer who's asked you to do this? What are they really looking to do? And I don't mean the customer in terms of your boss. I mean your customer in terms of the guy that's designing that new water system or that new energy system. What are they really trying to do? And then you can think of ways of making it even more efficient or productive for those customers as well. And that's what leads you kind of down the entrepreneurial journey, is putting those pieces together.
Okay, so that makes sense. So if they're working, let's say they're water engineers and they're thinking outside the box, but then they realize that they want to connect to different systems. How do they communicate with others who are experts in other areas better so that maybe they can collectively come up with a better unified system?
Well, I think that there's lots of ways to do that. So I think, using networks, using your colleagues, going to conferences, going on LinkedIn, and kind of reaching out to people that you're curious about what they're working on. Tell them what you're doing. I find that today there's so many ways to connect with experts, or people, and so that's what I would just encourage people to do. I spend a lot of time like on LinkedIn. I learned so much, and then just reaching out to people and say, I really like that article. I really like that podcast. Have you ever thought about doing this? And they're just very, very responsive. I think for people that are interested, particularly in getting into energy, because I think your readership is mostly civil engineers and
And
mechanical.
structural. Hmm.
Yeah, and structural. Yeah, so maybe more on the water side. The water industry needs a lot of really great people. That there's a lot of challenges in water, and it's an exciting area to be. It's becoming more interesting, more innovative as we try to solve the problem of climate disruption and the need to deliver water, even if the grid goes down. That's what I spend a lot of time on, is like if you look at like what happened in Asheville, or you look at what happened in Houston, and more, where these storms come in and they wipe out the electric grid. And like in Asheville, they were without water for 6 weeks. So if you think it's bad not to have electricity so you can't charge your cell phone, imagine not taking a shower for 6 weeks or not being able to boil water for food. So it's really important to try to figure out these, what are we going to do with water or energy, as these unpredictable climate events happen more and more.